Hello everyone, welcome to 10.6's notes. As we wind down, we got two more sections in chapter 10. And this one deals with the segments that happen inside of circles. And it's pretty cool how it actually works out. So here we go, yo. We've got what we will learn is this, using segments of chords, tangents, and secants. When two chords intersect in the interior of a circle, each chord is divided into two segments that are called segments of the chord. All right, big theorem right here. It's pretty easy again. It's pretty cool too. As you two chords intersect, you kind of make four little pieces, and they are proportional, people. So watch how cool it works. All you got to do is take, in this case, in example 1, I take x plus 2 times x minus 1 x plus 1, not sure why I said minus. Set that equal to the two segments of the other chord multiplied together. All right, so there you go. Now it's just a matter of solving. And some of these questions in this section, you'll see we get into quadratics. And I know you've solved them a little bit in Algebra 1, but we've been avoiding them this year. You'll solve them in great detail next year in Algebra 2. So check us out. Let's see if we can solve it without factoring or using quadratic formula or anything like that. Let's see. First times first. Outer. Inner. Last times last. So I can FOIL it. On the right-hand side, you just distribute. So x times x. And then x times 4. So now in this one, it's not going to end up being crazy for us because the x squareds are on both sides, so you can just subtract them out. So we can just be able to solve this one pretty easily. So 3x plus 2 equals 4x. So subtract 3x's on both sides. X is 2, but what do they want? They want to find ML and JK. So plug it back in. So you got to plug it back into everything. So I've got 4 for this segment and 3 for this segment. So ML is 7. And then the other one, we've got 2 and 6. So JK is 8. All right. Moving along. Oops, monitor progress. Pause it. Try this couple problems. Again, just breaking down the pieces of the segment. All right, we should look a little something like this. You've got 3 times x equals 4 times 6. Pretty simple. And we could, now that you guys know similar triangles, you could break this up and show why this works, because you've got vertical angles in the center there where the chords meet. And then you've learned that this angle, or this angle is pointing to this arc over here, so is this angle. So therefore the angles have to be congruent. So you have AA similarity, and then you're just setting up proportional sides for those triangles. All right, so 8 and 5, party people. All right, moving along. Now when you go outside the circle, tangent, secant, you have a couple little things here that are pretty cool as well. And theorem 1019 tells us that if you take the outside piece of this secant, multiply it by the whole thing, that you can set equal to the outside piece of this secant times this whole big thing. So a little phrase I like to say for this is the whole big thing times the outside piece equals the whole big thing times the outside piece. Whole big thing, outside piece, whole big thing, outside piece. So say it. The whole big thing times the outside piece equals the whole big thing times the outside piece. And here's an example of it. Example 2, find the value of x. So we just talked about, we got two secants, we're outside the circle, so we got to memorize that this whole big thing, 9 plus 11, times the outside piece, which is 9 in this case, has to equal this whole big thing, which is x plus 10, times its outside piece, which is just 10. When I say the outside piece, of course, I'm referring to the piece that's outside the circle. So now we just got to solve 8. So I've got 20 plus 9. I've got a 180. And then over here, distribute, I've got 10x plus 100. Subtract 100, divide by 10. The value of x is 8. And now try your monitor progress. Pause. All right. So in this one, we'll see what I was talking about earlier. 3 was easy. 9 plus 6 times 6 equals x plus 5 times 5. Solve it. But now number 4, you work yourself into a quadratic. And again, this is stuff I'm going to leave you with for Algebra 2 in the fall. All right. Last concept today, we got a secant. It's kind of the same thing when you have a tangent and a secant. Because a tangent, think about it, the whole big thing is the outside piece. So you're just going to take this EA and you're going to square it. All right, that's why you have that. The other secant is still whole big thing, ED times outside piece, EC. So example 3, let's see what we got. So I've got the whole big thing, 16, times the outside piece, which is also 16. So it really plays the same game as theorem 1019, but it's just a different, it's a secant and not a tangent. The other side is still a whole big thing, x plus 8, times the outside piece, which is x. And let's see if we can solve this one, or if it's a GASP type of problem. So 16 squared is 256. Over here we've got x squared plus 8x. So yes, so again, for example 3, we would end up having a quadratic. And this is not going to be something you're quizzed on this year. The setup is what I was mainly concerned about here. Example 4. Now, how we're going to use it, here's a good application of this. Find the radius of the aquarium tank. And it sets up, all right, well, we're out here outside the circle at C. We know this tangent is 20. And we know the distance from C to the circle E is 8. So I should be able to set up whole big thing times outside piece equals whole big thing times outside piece. Again, it's a tangent on one side, so it's 20 times 20, whole big thing times outside piece. And then my secant, whole big thing, so 8 plus r, or 2r, times the outside piece, which is just 8. So let's see how this shakes down. So 20 is 400, distribute 64 plus 16r. All right, so that's pretty good. So now when I subtract 64 on both sides, I've got 336 equals 16r. So divide that by 16. And my radius of this tank would be 21 and it's in feet. So whatever. So your radius is 21. All right, try that last one, pause it. I'll see what, we'll wrap things up here. See you guys in a second. All right, so for these last couple, again, 7 was non-doable because it broke down into a quadratic. Man, you guys did this in Algebra 1, but like I said, it's covered so much in Algebra 2 that I just let Mr. Bednar focus on it. So 5, whole big thing times outside piece, x times x squared equals the whole big thing times outside piece, 3 plus 1 is 4, times 1, x is 2. 6, x plus 5 times 5 equals 7 times 7, x is 4.8. So 10-6, pretty easy, my friends. Good luck on your homework.